Alright, so I thought since we only got to go through one of these in class that I would just work out a couple for fun here, and yeah, these just happen to be the ones that you got for homework tonight. So if you get done your homework by watching these videos, more power to you. At least you've worked through a couple of examples. Alright, so here we go. We got Josephina works between 10 and 30 hours per week at a pizzeria. She earns $6.50 per hour, but she can earn tips when she delivers pizza. So first they want us to define two variables represented in this situation. Okay, well, it looks like she can work a certain number of hours per week, right? So I'm going to make X be hours worked. Okay, and then Y will be what happens when she works hours. Well, she makes money, right? So total money made. Alright, so just as a double check, remember that the Y should be dependent, which means it should depend on X, which in this case it does. The total money made depends on the hours worked. Alright, so now what we want to do is we want to write some inequalities. Alright, in order to graph the possible solutions, we're going to have to take each of the pieces of data that we have here and graph that as an inequality from the equation, the inequalities that we write. Sorry, not equations. So Josephina works between 10 and 30 hours per week. So what does that mean? Well, that means that the hours worked, X, has to be greater than or equal to 10, and X has to be less than or equal to 30. Now, you could have written this any number of ways. I personally like writing it this way, with the x's greater than or equal to 10 and less than or equal to 30. But, you know, this will be easier for what we need to do with writing our inequalities in the system. So we've got two inequalities right here. X is greater than or equal to 10 and X is less than or equal to 30, because that's the hours. Now it says she earns $6.50 per hour. But she can earn tips when she delivers pizza. So now this is taking the hours that she works and the money that she makes dependent on that. So the total money that she makes is, now if she just works, then it's $6.50 per hour, right? So $6.50 times the number of hours that she works. Now the total money that she makes is not going to be equal to this, because she can earn tips if she delivers. So this is actually greater than or equal to 650x. All right, so now we have 1, 2, 3 inequalities, each of which we need to now graph. So we'll go to a graph. Now you'll notice I'm not including x values. I'm going straight, or sorry, the negative values. I'm going straight to the positives. Okay, now x can be anywhere from 10 to 30, so maybe if we just go by 5s, so 5, 10, 15, 20, 25, 30, and so on and so forth. And I can do the same thing for the y-axis, 5, 10, 15, 20. Maybe, maybe not. I mean, it doesn't really matter. I don't really know what I need to go by yet. Oh, 650x. So maybe if I go by some other number, it'll be helpful. I'll work on the y values later. So here we go. We've got x is greater than 10. So obviously this is part of that. What are the other points that have x values of 10? Remember, when we graph, we're going to treat it as x equals. So if I move to the side, if I move over here, that now has an x value of 15. So that doesn't fit. I need it to be equal to 10. And so I'm going to move up, and you'll notice that as I move up, each of these values here has an x value of 10. So there's one line, and I need to show all the values greater than that. So that's going to be shaded off in this direction. I'm going to do it lightly because I'm going to have 3 graphs here, and this will be kind of confusing if I have too much going on. So now we're going to go on to another color. So we've done the first one. We'll do x is less than or equal to 30 now. So again, that's an x equals. So that's going to be another vertical line straight at 30. Note, oops, sorry, that should have gone straight through there. Note that every point on this line has an x value of 30. The y values can change, but the x value is always the same. So I've got a y. Now x is less than or equal to 30. So less than or equal to 30 is going to be to the left. Now if you don't believe me, test a point. You're welcome to test out 0, 0. If I put in 0 for x, 0 is less than 30, which means I need to include that point. So I'm going to the right, to the left. Usually I have the excuse of it's my right, your left, because I'm working on the board, but here it's all the same. So there's the left, everything to the left. Now it's overlapping obviously in between the two bars. That makes sense because the hours worked has to be between 10 and 30. So all of these show that. Okay, so now Josephina received, oh, sorry. We've got the y is greater than or equal to 650x. So probably the easiest thing to do here is just to, the y-intercept, of course, is 0. It's in y equals mx plus b form. So I've got a y-intercept here. So maybe if I make these hash marks something nice that works with the x values that I have, I'm going to go ahead and put 5 in for x. And if I put 5 in for x, I'm going to have 650 times 5. So 650 times 5 would be 32.5. And so I'm just going to make this one 3250. Okay, because at 5, I'm going to be up at 3250. All right, and then the next one will be, next point I'll put at 10. So if I put 10 in, that should be 650 times 10, which will be 65. So each time I just need to go up by 32.5. And so that will go up to 97.5 and 130. So I'm just adding 32.5 each time, so that each time I go over, I can go up that little bit. And so that's this line. And of course, I'm looking for y is greater than. So if I plug in a point, I'm not going to do 0, 0 because the line goes through that, but I can plug in any other point. Maybe I'll just put in 5, 0. So if I put 0 is greater than or equal to 650 times 5, then that will be 0 is greater than or equal to 5 times 650 would give me 32.5, and 0 is definitely not bigger than that. And so since I tested this point and it was false, that means I need to shade upwards. And you can tell where they're all overlapping here, where it's green, blue, and gray, which means that my final answer, let's see if I can get a little bit better. No, oh, there we go. Draw. There we go. So a nice highlighter would work well there. So all of this is solutions. So this is graphing the solutions. And it's kind of nice on this one note here. So there we go. Those are my solutions. All right. So just as a review, first we wrote the equations and we made sure that the equations matched the, or sorry, inequalities matched the information given to us. So we wanted x to be more than 10, x is less than 30. We graphed those two lines, so she had to work somewhere in between here. Then we needed to relate the money to the amount that she works, and so we then made the inequality that the amount of money that she works is more than 650x, 650 per hour times the number of hours that she works. We graphed that. If you want, you can put this on a normal XY and you can go up 6.5 over 1, up 6.5 over 1, and you can do that just as easily. The reason why I did it this way is just because it worked a little bit nicer for my graph. And so I plugged in a value, I put 0 in and I got 0, and then I put in 5 and I did 650 times 5, and so that way you can get various points. Okay, from that point we have essentially all the solutions. Says if Josephina received $17.50 in tips and earned a total of $180 for the week, how many hours did she work? Well, if $17.50 is tips, then what we want to do is we want to take the 180 and subtract the $17.50, which will give us $162.50. And so I'm going to put $162.50 in to this equation right here, which is how much she made without the tips, right? And so we just go 162.50 is equal to 650x. Remember the inequality was there because we wanted to include the tips. And so here we just want to make sure that this is the money without the tips because that's the 650x. And so once we have that, we can divide by the 650 and we should get, oh, about 5, 10, 15, 20, 25. All right. And so 25 hours is how much she worked that week. All right, so that's the first question. I'm going to go ahead and stop it because this is getting a little long. If you want to see another example of this, then go ahead and look at the other video. Ciao.